Hello, this is Energy 101. We're looking at the third module, which is going to look at resources, energy resources. We talked in the first section about the energy needs for society and why we need them and where we use them, and now we're going to talk about where that energy comes from. So we're going to talk about the natural energy sources that we currently use in order to supply the needs that we have. So we specifically talked about the energy needed for buildings, for manufacturing goods, and for transportation. And by the way, one thing I may not have mentioned, in manufacturing, that includes manufacturing of food, farming, and the energy required to produce the food that we require for nutrition is under the manufacturing sector. But we're going to look at the sources today, find out where they're coming from, not in the future, not in the so much in the past, although we'll look at that briefly, but mainly where are we getting this energy from. Right now, we're getting most of it from hydrocarbon supplies. Coal we're getting 20% from. 20% of our total energy used comes from coal. Coal is our second oldest form of energy, basically. Wood was primarily the first, falling under biomass. But coal came into high demand in the 1800s in the steam engines that were used. And then we had oil. Oil, of course, came about with the advent of the automobile primarily. Oil demand started being increasing, and the simultaneous development of oil supply and the automobile went together. One fed the other. And then 36% of our energy supplies come from natural gas. That's the total energy supplies. We'll see that overall in a few minutes. But uranium, nuclear, accounts for about 9%. So we're up to about 46 and 36, so that adds to about 80%. That supplies almost 80-some% of our total energy supplies. When we look at the renewable sources that we're getting today, not the future, but today, biomass is the biggest one, where, just for example, wood is primary biomass. We use a lot of wood waste and wood resources. For instance, paper plants, pulpwood plants, that uses pulpwood and then has a wood waste that is burned to create their own energy. So we use a lot of wood, but we're also using a lot of corn to produce ethanol that's mixed with gasoline. We're using about 30 to 40% of our corn national production in the U.S. to produce ethanol, 30 or 40%, a big chunk of it. And of course, we're in a situation there of competing for between food resource of corn and energy resource for corn. So that's a conundrum that cellulosic ethanol, that we'll cover later in the course, could resolve. But biomass supplies in the primary form of wood and corn, plus there's some others, is about 5% of our total energy supplies that we use. Dams, hydro dams, water dams is a renewable resource. Of course, the biomass, by the way, is renewable also, because we grow corn every year and we grow wood every year and harvest it, and then grow again for another year before you harvest it. In the case of wood, you generally let it grow for about 7 years. But hydro is all renewable. Hydro, you let water fall from on top of the mountains down to the valley, and in the process you put it through a hydroelectric generator it converts the energy stored in that elevation, the water being at some high elevation, converts it into electricity. But it's recycled. The water then in the ocean and the lakes down at sea level is evaporated and lifts up into the clouds, and the clouds drift by wind over the mountains, and then it rains in the mountains and pumps the water from sea level back up to the top of the mountains where we can use it again to flow down through the dams and again generating electricity. Wind has seen a real big increase of late in the last several years, and it's 1.2%. We hear a lot about wind and we hear a lot about solar. You can see down below, solar is less than 0.2%. Wind is about 1.2%. So we're getting about more than six times as much energy from wind than we are from solar energy. Geothermal is using the hot earth far underground. In some cases, you drill a hole in the ground and you get hot steam coming up, but we're getting actually more energy from geothermal, the hot underground, than we are from solar at the current time. So one of the reasons for this is solar is very expensive, geothermal is not as expensive, wind is a little cheaper. So this list basically follows the economics. We get more energy from those that are more economical or cheaper, and less energy from those that are more expensive in end user consumption dollars form. So if you look at this in a pie chart, you can get a better visual of what all these percentages are and how they compare. You start with the coal, which is about 20% in the blue up on the upper right-hand corner, and then you move down to the red. Natural gas is about 26%, and then you move around to oil, which is 36%. Notice oil is the largest consumer, not the consumer, the largest supply that we have. And essentially, most of that oil goes to transportation. We'll look at where this energy goes later on. But all energy is not created equal, so to speak, both in value. For instance, oil costs about 5 times more right now per unit of energy than natural gas and coal. So oil is very expensive relative to natural gas and coal. So any place you can use natural gas and coal and displace oil, we pretty well have done it. Then nuclear is 9%. Of course, that's our nuclear power plants. And then you have the biomass that we mentioned, primarily wood and ethanol up in the light blue. And then hydroelectric plants is about 3%. Wind then is about 1.2%. Then you have geothermal, a very narrow sliver you can barely see, is 0.25%. And then solar is the smallest sliver there that's vertically upward. So those are our energy sources, and that's where we get our natural energy from that occurs on on the Earth's surface, and we can easily extract from the Earth, be it wind or coal, and utilize it to satisfy our society's energy needs. Thank you.